All right, so in the previous lesson, we learned that the square root of -1 is equal to I. So using that fact, we can start to simplify powers of I. So if we look at I squared, that's the same thing as saying the square root of -1 squared. And since we know that square rooting and squaring are opposite operations, they cancel each other out, and we're just left with -1. So then if we take I cubed, using a property of exponents, we know that we can actually break that down. Well, there's a couple different ways we can do it. We can say that that's square root of -1 times square root of -1 times square root of -1. And we know from the previous result, I squared is equal to -1. And we know that the square root of -1 is equal to I. So -1 times I is equal to -1. And then if we think about I to the fourth, we can really break that down into I squared times I squared. So really what we can do is break up this exponent however we want. We know I squared is -1. So this is the same thing as saying -1 times -1, which gives me a +1. So these four results, I, -1, I, 1, is what we're going to simplify powers of I to. All right, so using the results that we just looked at, we know that I squared is equal to -1, I cubed is equal to -I, and I to the fourth is equal to 1. So using those results, we can rewrite I to the fifth as I to the fourth times I. The reason we're going to do that is because we know that I to the fourth is equal to 1. So we know that this becomes 1, and 1 times anything is just itself. So we're actually just left with I. So I to the fifth simplifies down to I. Same thing, we can break up I to the sixth. Well, we know that I to the fourth goes into 6 once. To get to I to the sixth, we need 2 more. And again, we know that I to the fourth is equal to 1. So we're just left with I squared. And as we see, I squared is equal to -1. For I to the seventh, using the same logic we've been using, we can say that's broken up as I to the fourth times I cubed. And the whole reason for doing that is because I to the fourth is equal to 1. So we're just left with I to the third power, I cubed, which from the previous result we see is just equal to -I. And then lastly, for I to the eighth, we can rewrite that as I to the fourth times I to the fourth, or we can say I to the fourth squared, since 4 times 2 is 8. And we know that I to the fourth is equal to 1. And 1 squared, or 1 times 1, is equal to just 1. So looking at the next line, I to the ninth, well, we can rewrite that in terms of I to the fourth. Again, the reason for rewriting that in terms of I to the fourth is because we know that I to the fourth is equal to 1. And 1 times anything is just itself. However, we know that 4 goes into 9 2 times, so that will get you to I to the eighth. We need one more I to get us to I to the ninth. This whole first part, I to the fourth, simplifies to 1, so we're just left with I to the 10th, well, 4 goes into 10 2 times. That gets us to 8. To get to 10, we need 2 more i's, so I squared, and we know that I squared is -1. I to the 11th, again, we're going to write it as I to the fourth, goes in 2 times, which will get us to 8. To get to 11, we need 3 more i's, so I cubed, and I cubed is -I. And then lastly, I to the 12th, we know that 4 goes into 12 3 times, and we know that I to the fourth is equal to just 1, and 1 cubed is equal to 1. So as we can see here, we kind of have a pattern. I, -1, -I, 1, I, -1, -I, 1, I, -1, -I, 1, and this pattern is going to continue as the numbers go on. So you can think of it as kind of like a cycle. So when we're simplifying powers of I, our answers, our final answers, is either going to be I, -1, -I, or 1. So to fully simplify any radical, we want to simplify it down to one of those 4 answers. So the way that we're doing this is we're basically going to take our exponent and divide it by 4 because we want to rewrite everything in terms of I to the fourth, since I to the fourth is equal to 1. And then we're going to determine the remainder because that's really going to determine what our answer is going to be because that's how many more i's we need to get to the power that we're looking for. Then we're going to rewrite the power using the remainder, and then we're going to simplify our expression. So let's take for this first example, we have 133. So to do this, we're going to do 133 divided by 4. So as we can see here, 133 divided by 4 is 33.25. So that basically means that 4 goes into 133 33 times, but it doesn't quite go in evenly. So we can actually rewrite this as I to the 4th to the 33rd power. And 4 times 33 will get me to 132, which isn't our power that we need. In order to get to 132, we need one more I, so I to the first power. So 4 times 33 gives you 132, and then plus 1 will get us to 133. So that's how we rewrite it in terms of I. These are equivalent statements. Oops. The I to the 133 is the same thing as I to the 4th to the 33rd power times I to the first power. So the whole reason for doing that is because this whole term simplifies down just to 1, since we know that I to the 4th is equal to 1. And then we know I to the first is just equal to I. So this just becomes 1 times I, which is equal to I. So I to the 33rd power simplified down is equal to I. All right, so for the second example, we're going to do the same thing. We're going to do 76 divided by 4, which is 19. So we're going to rewrite this as I to the 4th to the 19th power. 4 times 19 gives you 76. So we already have an equivalent statement, so there's no remainder. So in that case, we know that I to the 4th is equal to 1. So our final answer for this one is just going to be 1. All right, so looking at a couple more examples, I to the 214th power. So we're going to take 214 divided by 4, which is 53.5. And we're going to rewrite this in terms of I to the 4th. So 4 goes into 214 53 times, but that only gets us to 212. So to get to 214, we need 2 more i's, so it's going to be I squared. This first part is equal to 1, and then we learn that I squared is equal to negative 1, so 1 times negative 1 is equal to negative 1. All right, last example, 127 divided by 4 is 31.75. So I'm going to rewrite this as I to the 4th to the 31st power. 4 times 31 will get you to 126. Or not 126, 124. And then in order to get to 127, you need 3 more i's. So I to the 3rd power. And then this simplifies down to 1, and then I cubed is negative I. So my final answer is negative I. So here's a little trick. We can actually use the decimal to figure out what our remainder is. So if we think about how many quarters 50 cents is, that's 2 quarters. So this means it has a remainder of 2, which is where this exponent comes from. In this case, 75 cents is 3 quarters. So that's a remainder of 3, which is where this 3 comes from. So if it's 0.25, that's a remainder of 1. If it's 0.50, that's a remainder of 2. If it's 0.75, that's a remainder of 3. And if there is no decimal, so 0.0, that's a remainder of 0. All right, now let's take a look at a couple of these practice problems. So for the first one, we're going to do 82 divided by 4, which is 20.5. So we're going to rewrite this as I to the 4th to the 20th power. That gets us to 80. We need 2 more i's to get us to 82. Again, looking at this remainder, 0.5, that's 2 quarters, so that's where the I squared comes from. This is equal to 1, and I squared is equal to negative 1. Oops. So my final answer is just going to be negative 1. All right, number 3, taking 39. So we have 39 divided by 4, which is going to be, let's see, 4 goes into 39 9 times, because 4 times 9 is 36. So 9.75 remainder of 3. So this is going to be I to the 4th times 9. This gets me to 36. To get to 39, I need 3 more i's. So this first part is 1, and I cubed is negative I. So 1 times negative I is just going to be negative I.